Anil ji,
Yes, ma'am.
right now we are having around 16 participants. We can wait for another 2-3 minutes and then we can begin.
Yeah, sure.
And I would request participants, if, in case they have any queries, they can post the same in chat box or they can also raise hand so that it's a two-way interaction.
Hello. Yeah, good morning.
Anilji, we can start the session.
Ma'am, our expert is likely to join. He's having some technical issue. As
Okay,
soon as
okay.
he will join, we will start our session.
Anilji, before we start today's sessions, I would request you to kindly brief our participants how they have to submit the assignment. If you can give that instructions again.
Ma'am, actually, I'm in with touch with our expert. He's having some issues.
Sorry.
Ma'am, I'm on call with our expert. He's having some technical issue.
Okay. Um,
Give me a couple
Mr.
of
Datta has
minutes.
joined.
Yeah, but he's having some issues.
Okay, okay. हेलो हाँ जी दिनेश हाँ जी
Hello. I think it is okay now.
Dr. Kaur, we can start our session.
शेयर वाला खोल दीजिएगा. Hello.
Yes, sir. Yes, sir.
Share content is still not on.
Sir, we will give you shortly presentation option.
It gives lot of hiccup in the morning.
No problem, sir. Welcome to the second day of 3 days online training program on disaster management for Indian Oil Corporation Limited, jointly organized by National Institute of Disaster Management, Ministry of Home Affairs and Indian Oil Corporation Limited from 1 to 4 2020. Myself, Dr. Harjeet Kaur, currently working in GMR division, NITM as a young professional, and I will be the moderator of today's session. Before we proceed with today's session, let us quickly recapitulate our yesterday's session. We were graced by the presence of Mr. M.R. Dwivedi, CGM Indian Oil Corporation Limited, and Professor Surya Prakash, Head GMR Division, NITM, in the inaugural session. Professor Surya Prakash, Head GMR Division, NITM, in his keynote address highlighted importance of educating people about disaster. Disaster education is a functional, operational, and cost-effective tool for risk management. It is important for vulnerable people to learn about disaster. Trained people can better protect themselves and others. In this regard, planning and designing comprehensive educational programs are necessary for people to face disaster. Professor Surya Prakash rightly highlighted that vulnerable individuals should be designed and implemented by the well-known professional training teams, and adopting comprehensive and standard training programs for these. Accordingly, the impact of these programs should be assessed to identify their strength and weakness. Mr. Dwivedi, CGM, HSC Indian Oil Corporation Limited, in his inaugural address, motivated and enlightened participants regarding the 3 days program and initiates and workers of IOCL towards disaster risk reduction and resilience with their vast experience and wisdom. He also highlighted that the main objective of this 3 days training program is to develop better understanding basic concept of HVCR, disaster management cycle, national disaster management plan and template, mainstreaming DRR in development activities, India's preparedness and disaster mitigation in oil sector, response and preparedness disaster risk reduction measure in cross-country, natural gas pipeline, incident response system, IDRN and supply chain management. Mr. Anil Katath, young professional, Center for Hill Area Development, GMR Division, NIDM, talked about the National Disaster Management Plan and template. He mentioned that the plan is to make India disaster resilient. It will help to maximize the ability of the country to cope with disaster at all levels by integrating disaster risk reduction into development and by increasing the preparedness to response to all kinds of disaster. The plan takes into account the global trends in disaster management. It incorporates the approaches in the Sendai framework for disaster risk reduction, which is an arrangement under the auspices of the United Nations to which India is a signatory. The implementation of the plan requires sincere cooperation of the center and state coordination among various departments, as well as the active participation of the civil society, community-based organization, communities, and the private sector. While the plan provides much clarity and sound framework, only when all the stakeholders work together as a team, it will be possible to realize our goals of making India safer by significantly reducing disaster risk and drastically improving our preparedness. Shri Ved Prakash Mahavar, former director ONGC, underlined that with escalating disaster risk, particularly in petroleum sector, there is growing conscious that the key to sustained risk reduction lies in mainstreaming the reduction of risk in development, and essentially this is the process of incorporating the key principle of disaster risk reduction into development goals. On the other hand, mainstreaming requires the analysis of flow. Potential hazard event could affect the performance of policies, program, and project, and it needs to look at the impact of same policies, programs, and project on vulnerability to hazard. Our last speaker, Shri Jodev Lahiri, Chief Manager Engineering and HSC Oil India Limited, presented the last lecture of the program on the India's preparedness in disaster mitigation in oil sector. During his lecture, he shared several past disaster incidents and touched upon several important points, and also shared lessons learned from oil and gas disaster in India, such as crucial time lost in planning and arranging resources to tackle the situation. As a result, the situation get aggravated. Improper evaluation, analysis, and attacking the incident, failure to respond in time by right in charge. So that was a recap of yesterday's session. Now for today's session, we will join by Shri Hirak Datta. Hirak Datta, Executive IOC, former ED, OISD, MOPNG, and former Advisor and Head Safety, Naira Energy, Dr. SP Garg, Advisor, GAIL India Limited, and former Executive Director, and Lieutenant Colonel Dinesh Chandra Vasishtha, Joint Director, NITM. During the technical session, there will be presentation, and once the presentation are over, we'll have a question answer session at the end of each presentation. We will also have an interaction discussion Q&A session at the end of each presentation. And if you have any questions for the speakers, kindly use Q&A window only to raise question. Now for our first presentation, we have with us Datta, ex-IOC, former ED, OISD, MOPNG, and former Advisor and Head Safety, Naira Energy, who will be sharing his vast knowledge and experience about response and preparedness. Mr. Datta has more than 37 years of experience in process designing and engineering, operation, troubleshooting, safety management, project management, and human resource management at various refineries and at the Corporate Office of Indian Oil Corporation Limited. He has authored in papers in national and international journal, and he has presented at a conference around the world. Mr. Datta earned a degree in chemical engineering from Jadavpur University and condensed MBA at Indian Institute of Management in Ahmedabad. Sir, I pass on stage to you, sir.
Thank you for nice introduction. I'm talking to my own Indian Oil people, so I will. It's a great pleasure that NIDM has again invited me to speak today on this very important topic of national importance. And last time I spoke to Indian Oil people only, before I talked to HPCL people. And thank to the organizer for again giving me an opportunity. It's a very, very interesting topic, and we need to work on this area a lot. Let me. Am I audible?
Yes, sir. Okay. Audible. Yes, sir.
Let me remove that box which is coming on the right hand corner.
Yes, sir. Drop it down, sir.
Yeah, it's okay now.
Make it full screen, sir. Yeah, it's clear, sir.
Yeah. So, once again, thank Harjit for a lovely introduction, and very, very good morning to all the delegates from my own company, Indian Oil Corporation. I will be speaking today on response and preparedness, and I have been allocated some 40 minutes time, I hope, Mr. Harjit, Madam Harjit Kaur. So I will try to talk about 30-35 minutes, and then I will leave 5-10 minutes for the question answer session. So that's the plan for the today's session. Whenever you talk about disaster mitigation or disaster management, the very first thing which is very, very important is how do you reduce the risks of the disaster. And so the basic funda of disaster reduction is a systematic approach of identifying, assessing, and reducing the risk. If we can identify the risks involved in our operations, in our business, in our industry, if you can assess what is the quantum of that risk, and if you can find the risk mitigation measures, then we have won the battle. Then we have won the war. So basic fundamental of disaster preparation starts from which is a systematic approach of identifying the risks, assessing the risk, and reducing the risks. And it aims to reduce the socioeconomic vulnerabilities. As I move on, I will give you some examples, some case studies, which I thought I will share with the IOC people, with the delegates. And it aims to reduce the socioeconomic vulnerabilities and other hazards. So whenever a big risk or a big catastrophic incident takes place, it triggers many other hazards. So how do you reduce those hazards and reduce those socioeconomic vulnerabilities? As we all know, I am not talking again on this. Indian oil and gas industry is highly hazardous because we handle highly flammable petroleum products, and it operates at a very high temperature and very high pressure. Pipeline operates at high pressure also. So, and India has more than 45,000 kilometers of pipeline. And as my pipeline friends know it very well, more than 30% of the pipeline has outlived its design life. So therefore, there is a great challenge as to how these old and aging assets, how to keep these old and aging assets in a reliable manner so that when we operate, there is no unsafe situation. It can operate in a smooth and safe manner. And therefore, it requires special attention to avoid major catastrophic incidents. So therefore, when we talk about management of aging assets, it's about asset integrity. How reliably we can manage these assets reliably so that there are no catastrophic incidents, particularly when 30% of India's oil and gas pipeline has outlived its design life of 25 years. By no means I am saying that pipeline which are more than 25 years cannot be operated safely and smoothly. No, I'm not saying that. There are many pipelines in the country and many pipelines outside the country in the US which has been operating for more than 50 to 60 years. Guwahati-Siliguri pipeline, a unique achievement of Indian Oil Corporation. A Guwahati-Siliguri product pipeline is operating for more than last 60 years. And it is to the credit of Indian Oil pipeline people and Indian Oil people that they have been able to manage this asset, which is more than 60 years old, very, very effectively and very, very efficiently. And that's the reason that we don't have any incident in the Guwahati-Siliguri pipeline. Now, coming to the risk reduction in industry approach, how do we reduce the risks? There are two basic approach. One is the least preferred approach, which is PPE and administrative controls. I am not saying PPE is not important. PPE is important. Wearing helmets, safety shoes, gloves, etc. is important. Administrative controls are also important. So you need to give some administrative controls, and those are important. But what are the most preferred option for the industry, and which most of the industry and Indian Oil definitely does, is the engineering control, which is very, very important. And as I move along, I will talk about some of the engineering controls which has taken place, which has been done, which has been undertaken by the Indian Oil Corporation and by many other industry to avert many of the catastrophic incidents and thereby stop the disaster to happen. So the focus is on how do you, through good engineering controls, reduce the risk. How can you isolate the risk? We'll talk about it. How can you eliminate the risk? And therefore, when you talk about risk reduction, design is very, very important. Inherent safe design. If you can bring in inherent safe design, we'll be able to do a lot of good work in reducing the disasters, in ensuring that we operate in a safe, reliable, and smooth manner. So in that context, maintenance is also very, very important. And in that context, operation is also very, very important. So when you talk about risk reduction in totality, look at the bigger picture. Bigger picture is design has to be good. We need to know how to operate, and we also need to know how to maintain things properly. These are the three important parameters. Unless we attack all these three things, we will not be able to reduce the risks. And if you don't reduce the risks, there will be any unsafe situations. There will be catastrophic incidents which may lead to disasters. Our basic object is how to stop these disasters to happen. And if that happens, what should be done? Okay. Now, whenever we talk about emergency response risk assessment, now look at this. Risk has two elements. One is severity risk and second, the likelihood of the risk. Now, if you look at this, look at this chart. I have shown as A, E, F, G, H, and the likelihood is 1, 2, 3, 4, 5. This is very simple chart to understand. The 5 is the likelihood is very high of risk is very high, and A is fatal. Now, if that is the case, where likelihood of a risk is very high, and in terms of severity, there are chances of fatality, that is considered to be the most dangerous area. Similarly, 1 is where the likelihood of risk is not there, and then it is considered as a very low risk part area. We are all sitting in the room. Suppose a ceiling fan falls on our head, we are going to die. But the likelihood of ceiling fan falling down, the likelihood is very, very low, negligible, and so therefore that risk is very, very, very low. So this is what I thought I will tell our friends, my dear IOCLs, that emergency response risk assessment starts with risk severity and risk likelihood. So we need to understand this important issue very, very much. Friends, today is 3rd December. And tomorrow is 4th December. 4th December is a very, very sad day for us. 4th December 1984, we had Bhopal disaster, Bhopal gas leak. And Bhopal disaster is one of the worst disasters which the country has faced, which the world has ever witnessed. Bhopal disaster. So what do we learn from this Bhopal disaster? I thought I will share with the participants about the Bhopal gas disaster strategy. Why did it happen, and where did we went wrong, and what lesson it learns in terms of managing the industry, in terms of responding to such sort of emergency. So let's start talking about Bhopal disaster, and before that, we must also pay our homage to thousands of people who have lost their life in the Bhopal gas disaster tragedy. Many of you probably may know that Bhopal gas tragedy, which was Union Carbide, the fateful incident happened on December 4th, night of December 4, 1984, which is just tomorrow. And what had happened in the Union Carbide factory, which was producing pesticide, the spillage of highly toxic methyl isocyanate, MIC, MIC, were leaked in large quantity. Now, large quantity of methyl isocyanate leaked from the Bhopal Union Carbide office, and in that incident, more than 5,000 and tens of thousands, more than 5,000 fatalities. It is one of the worst disasters in the world, and tens of thousands of people were taken ill. As I mentioned, it is one of the worst process safety failure, one of the worst disaster witnessed by industry till date. No, why did this happen? Let's look at it and let's try to find out what are the various engineering controls, what are the various technological controls we need to bring into our system so as to avoid such type of major disasters. Now, spillage of highly toxic MIC, that is methyl isocyanate, in large quantity from pesticide plant of Union Carbide to atmosphere. Now, what caused the incident? Now, they were storing, Union Carbide was storing 55 tons of MIC, while daily usage was only 5 tons, was a major error. That means your daily requirement of MIC was only 5 tons, and you stored 55 tons of MIC, which was not required to be stored in such a high quantity. Now, MIC must always be stored at 0 degrees centigrade. But the refrigeration system was not working, and no care was taken to correct the refrigeration system. It was giving a problem for quite some time. People who have gone through the Bhopal case study, Bhopal tragedy, the Union Carbide story, they know that the refrigeration system was not working. And in case there is a MIC leak, there is a scrubber system. With the scrubber system with hydroxide, it could have easily neutralized the MIC. And therefore, the release of MIC, the toxicity of MIC could have come down, because through scrubber, through hydroxide, it would have been taken care of. But the scrubber system was kept offline and it was disconnected to flare. Now, the flushing of nitrogen pressurization line. Now, when the plant was, there was a choke in the line, in the chokeage in the line, and they were trying to dechoke the line with nitrogen pressurization and followed by water flushing. But the blind flange was not used while they are water flushing the line. And as we all know, you all must know that water and MIC is a highly exothermic reaction. Any amount of water which goes into the MIC storage tank or methyl isocyclyl storage tank, it is exothermic reaction. An exothermic reaction means it gives rise to huge rise of temperature, and as a result, the situation aggravates. It is actually as good as a runaway temperature, where huge temperature rise is experienced and delay, and there was a delay in response in handling the emergency. As a result, the poisonous mic leaked from the storage tank. As I mentioned, the scrubber system was kept offline and it was not connected to the flare line. So the Bhopal gas tragedy took place. And that's a very sad story which happened, which killed more than 5,000 people. So why did it happen? That's very, very important. When you talk about the preparedness part, this is very, very important to know why did it happen. Poor risk and hazard assessment. This is very, very important. Poor perception of the risk involved. The perception that MIC, that is methyl isocyanate and water, if they mix together, it will give rise to huge rise in temperature, exothermic reaction, and therefore flushing the choke line with water without putting a flange is very, very dangerous. This risk perception was not done properly. It was not understood properly, not understood properly. Absence of hazard operability studies, that was a very bad thing which was done. Poor risk management practices in toxic chemical facility. So coupled with this, there was a poor risk management practice in toxic chemical facility and failure to anticipate that what would happen. Now, around the Bhopal, there was a huge human settlement. Bhopal is a big city. So the Union Carbide failed to anticipate that in case there is a potential leak of MIC, how do you save the life of the people around? So this is one important thing. When you are handling disaster situation, we must know about our surrounding, that in case by God permit, this should not happen, but if leaks, toxic gas leaks, what are the measures we must take to ensure that human life is not injured? And safety and system related, what are the things where the flaw was there? Not evaluating safety levels needed for toxic facility close to human settlement, as I have mentioned. Not improving safety system even after audits and warning. What are the safety systems which were not improved and which led to such unsafe situation and catastrophic incident and a disaster? Is that refrigeration system was not working? Is a scrubbing system not working? Is a decision to store MIC in large scale is not permitted in many countries. And we stored 55 tons of MIC. That's a hazardous toxic material. When a requirement is only 5 tons, that's a major management mistake. So management decision mistake. So storing 55 tons of MIC while daily usage was only 5 tons was a major error. And then added to a transfer of experienced person to non-MIC plants. Due to the Bhopal gas incident, Bhopal tragedy, many experienced persons were transferred from the MIC plant to the non-MIC plant. And finally, which affected most is inadequate emergency handling and management system. Now, as a result of this, thousands of people died. Now, if you don't have emergency handling and management system, in case there are accidents, we will face with disaster. And similar thing also, I will share. The similar thing also took place very recently when styrene gas factory was being started up in Andhra Pradesh. Now we all know that if styrene leaks, and then if the styrene leaks, there will be fatality. And the styrene gas leaked from this, again, similar things. So it's a reminiscence of Bhopal gas incident. Styrene leaked from the storage tank. Again, the same reason. Styrene should have been stored at -20 degrees centigrade, but the styrene was not maintained at -20 degrees centigrade because the refrigeration system in the styrene storage tank was cut off every day in the evening. As a result, styrene polymerization reactions started. And once polymerization reaction starts, it is also an exothermic reaction. As a result, huge amount of styrene leaked from the styrene gas factory in Visakhapatnam at Hyderabad, which led to multiple fatalities and loss of not only human life, loss of lot of animals. So therefore, ladies and gentlemen, and my dear friends, it's very, very important to undertake the risk and mitigation, hazard assessment and risk mitigation measures. And then in the case of the styrene, as well as also in the case of Bhopal tragedy, there were not proper emergency handling and management system, which that in case something goes wrong, what should be done. But today, luckily, in our country, in many of the oil installations, we have set up a facility, and therefore there are chances that in case, God forbid, nothing should happen, but in case something happens, we will be able to take care of that. Now let me a little bit talk about the lessons learned from the Bhuban tragedy. The conceptual framework on tragedy on such disasters and many disasters indicate that 80 to 85% failures are due to leadership and management failures, and only 10 to 15% are due to human error. Most of the time, people say that it is because of human error. It's not correct. Most of the incidents, 80 to 85% of the incidents happen place, catastrophic incidents, the disasters happen place because of leadership and management failures. Hazard assessment and risk mitigation measures must be carried out at the project appraisal stage. That is very, very important. So every place I mentioned, design is very, very important. At the design stage itself, do the hazard study, do the quantitative risk assessment study, do the hazard study, and after doing the hazard study, incorporate the layers of protection and risk mitigation measures. So that should be done at the nascent state of the design itself, at the project appraisal stage itself. Handling such emergency situation calls for setting up of EPER-DMP. Luckily, in our country, in every oil and gas industry, in all installations today, we have a ER-DMP, thanks to OISD, thanks to PNGRB, and thanks to NIDM, etc., who are following up and trying to educate people on ER-DMP, that we have set up the ER-DMP, and this ER-DMP will help us in a long way. Leadership commitment is prerequisite to manage disasters. Anyway, everywhere leadership commitment is a must. If leaders are not committed, if leaders are not committed into it, if they don't have that belief, then we will not be able to avoid such type of tragedy, and we will not be able to assure, because it means good business. So if leaders' commitment is there, we will not be able to achieve success. But since then, we had a lot of catastrophic incidents in India and elsewhere too. We had a Jaipur tire terminal. We have Tatipaka natural gas pipeline explosion. We have FCC incident in Vadodara. We have Unchahar boiler explosion. This Unchahar boiler explosion, as friends know, where multiple fatalities took place. And more recently, as I have mentioned, styrene gas leak at Andhra Pradesh. Luckily for Indian Oil and luckily for many other industries, we have taken a lot of measures, technical measures. A lot of engineering controls have taken place in the oil and gas industry, which has helped to ensure reliable operation, and which has also helped to ensure that risks have been brought down, catastrophic incidents have been brought down, and disasters have been brought down. So let's look at, my focus is on post Jaipur, post Tatipaka natural gas pipeline explosion, post FCC at Vadodara. What sort of measures have been taken place, have been carried out by the industry so as to ensure, which NIDM says, the well-being of people, which is the priority of Government of India, which is the priority of NIDM, about the well-being of people of India. Let's look what are the control, a number of control measures, both in respect of hardware and software upgradations have taken place around the oil and gas industry and many other industries to reduce the consequences and severity of risk. That's our prime job. We are engineers. Large number of engineers are attending the session today. Engineers' job is to ensure that large number of technical controls, inherent safe design, large number of hardware and software upgradations are necessary to ensure reliable operation. It's necessary to avoid major disasters. That's the job of ours who are working in industry. So let's look at some of the hardware and software upgradations which has taken place across the Indian oil and gas industry. I'm not talking about IOC, HPC, BPC, GAIL, oil, ONGC, every place, including the private sector, a lot of such things have taken place. And therefore, today, the industry is much safe than what it was earlier. I'm not saying we should be complacent. Yes, we have brought these technological controls. Now we need to have deep involvement, a culture. We need to build up a culture so that there is continuously, we can say that yes, through these measures which these giant organizations have taken, we will be able to ensure the smooth and reliable operation without any disaster. Hardware upgradations, as you all know, how Jaipur incident happened. The hammer blind, which was an obsolete equipment, have been replaced with double block and griddle valves across the industry. Additional layers of protection incorporated to avoid spillages and tank overflow. Many of the marketing terminals, many of the pipeline terminals, as you all know, we have all taken incorporated the additional tank overflow protection by incorporating a hardware switch. You have a high level alarm, high level alarm, and then you have a automatic high hardware switch which will automatically stop flow of liquid inside the tank, and therefore to avoid spillage. That has been done. That technological change has been done. You have given two radar gauges to continuously monitor the level of the tanks. So earlier it was one level gauge. Safety instrumentation and seal level. A lot of safety instrumentation. The safety instrumentation has been brought into the system. Seal level has been examined, and based on the seal level, critical layers of protection, safety interlocks have been built into the system. ESD, emergency shutdown system, has been built into the system in terminals, in pipeline terminals, as well as in refinery. Emergency shutdown system, PLC-based ESDs have been brought in. So this technological changes, this technological upgradation, this technological automation has been brought into the system in hardware operation. And in terms of maintenance, as I have mentioned, today the upstream sector is doing risk-based inspections. And in pipelines and in refineries, we are doing reliability-centric maintenance to improve asset integrity. That's very, very important. Conditioning monitoring of supercritical equipment. In refineries, we are doing continuous condition monitoring of supercritical equipment. That's very, very important. Now, if you do those things, we will be able to ensure that our assets remain safe and we do not endanger the environment, we do not endanger the life of the people. And focus, therefore, has been always on automation. Focus has been on, tomorrow the focus will change from automation, digitization. A lot of digitization work is also going on in the entire oil sector. Focus is on inherent safe design. So these are some of the hardware upgradation which has taken place. And I have not mentioned about the hardware upgradation which has taken place in the firefighting facilities. Jaipur, we had only 144 cubic meter of water flow through the water monitors. Now today, the entire water spray system has been changed to HVLRs of 5,000 GPM, of 2,000 GPM. Remote operated HVLRs have been incorporated into the entire plant, be it marketing terminal, be it refinery, be it pipeline, be it in the upstream sector. So we have only 144 cubic meter of fire water monitors, and today we have 5,000 GPM of HVLRs which have been brought into the system so as to ensure that in case there is a major disaster, how do we fight with that fire? You have MEFG which has been brought into the system so that there is an oil spillage. How do you fight that oil spillage and kill the fire at the nascent stage itself? Those sort of tremendous changes has been done in the firefighting facilities. So one hand, technological upgradation has taken place. On the other hand, tremendous changes has taken place in the firefighting facilities. One more thing which is required to be done, which I will say towards the end, is we need to now set up emergency response centers for a conglomerate of industries. Big water line, we have 4-inch and 6-inch water monitors. That will not do. The big water concept is at least 10-inch to 12-inch diameter water hoses are required to fight mega fire in terms of if there is a major hazard in a conglomerate of industry. Software upgradation which has been done and which NIDM is doing, which every industry is doing, there is renewed thrust on training and to retrain not only our own employee, but IOC, HPC, BPC, GAIL, etc. Oil, everybody is putting a lot of thrust on training the contract labor. That's very, very important. Train the contract labor. So that has been undertaken in our system. Simulator-based training on advanced technologies, refineries and many other petrochemicals, and even in pipeline, we are going to train people. We have been training people on simulator-based training technologies and advanced technologies. Hydrocracker, FCC, cracker operations, they are very, very they are trained on simulator. Focus on reporting near misses and leading indicators. Not focus on lagging indicators. Lagging indicators are important, but more important is the leading indicators. And therefore, every oil installation study is focusing on near misses and leading indicators. Job safety analysis, task observation, communication. That's very, very important. Many incidents have taken place because of communication barrier. And in here, when you were talking about managing disaster, communication must be very, very strong, not only with our own team, but communication with the people around our installations. We need to sharpen our communication skills. Managers need to sharpen their communication skills. And therefore, job safety analysis, task observation, and communication. These are some of the software upgradation which has taken place in the entire oil sector. Trainings have been given. Development of EDA, DMP for every installation. Thanks to PNGRB, thanks to ISD, thanks to the oil companies itself, that QRA has been done for most of the installations. And based on the QRA, DMP has been made. Only thing I will say that please undertake the QRA through a reputed consultant. There are mushroom of consultants we must avoid. Do the QRA properly, and based on the QRA, if you are doing the DMP, and then we will ensure that our industry remains safe, that the people around the industry are not affected. Mock drills are being conducted. That's the best part of it, which is being done in the oil industry. Mock drills, both on-site and off-site. Every quarter, some companies, some installations are doing on-site mock drills every 2 months on various scenarios. Not only one scenario, on various scenarios, mock drills are being done. This mock drills helps us in improving our preparedness. And after the mock drill, there is a debriefing session, which is done in the conference room, a meeting which is chaired by ED himself, to see where did we do mistake in our mock drill. What was the gap in our mock drill? The different scenarios: a valve failure, a pipeline, 5 millimeter pipeline leak, pipeline hole, or a tapping in the pipeline. Do the mock drill, has been done, and what sort of actions are required to ensure that risk mitigation measures have been taken. Debriefing sessions, educate the people. Those are being done continuously on a regular basis by the industry, and that have resulted in giving good results. Off-site mock drill is done once in a year or once in 6 months. And in this, we are involving, people must involve, and people in the oil industry, people are involving the district administration, the pollution control board, the state law and order machinery, the district hospitals. So we are checking the preparedness in case the level of the risk goes beyond the boundary of my factory. We do offsite drills, and in offsite drill, along with the district administration DM, we also check the preparedness of the hospitals around, not only in our installation, but hospital around the area, whether they are prepared that in case there are some catastrophic incidents and people get injured, how quickly we are able to put them into hospital and treat them. How quickly state law and administration comes over and takes over. How quickly the highways are closed. How quickly we can make a barricade so that people do not get affected. So these are some of the hardware and software upgradation which has taken place post this incident, which has helped the oil industry. And if we continue to do this, we will be able to show, I'm sure that, and along with the DMP and doing mock drills, I'm sure that we will not have any disaster in our country. Now, disaster management legislation in India, I will quickly go through it. Many of you know, we have Factories Act, we have IHSE rules 1989, we have Chemical Accident rules, which is framed under EPA, we have DM Act, which is establishment of National Disaster Management Authority, which frames the policy on disaster management and enforcement and implementation. And we have DMP Regulation 2010, which is regulation which was framed under PNGRB under Act 2006. And it has 3 levels of emergencies: level 1, level 2, and level 3. Level 1, as you all know, as I mentioned about it, is managed and contained effectively and safely within the site with our available resources. So, do the on-site emergency. Level 1 means that whenever there is a problem, an emergency, we were able to effectively manage the emergency with our own available resources, and no impact goes outside. Level 2 is cannot be managed and contained effectively and safely within the site with available resources. Every oil companies have constraints in terms of resources. You cannot have all the resources within your premises. So you may have some constraints. So therefore, we require help of mutual aid members. And all the oil companies, let me tell you, all the oil companies have signed mutual aid partners with the other oil companies. IOC have signed mutual aid partners with BBC, HPC, ONGC Oil. That is around the industry, around that, even with the port authorities, even with the district fire and firefighting facilities. So therefore, in any firefighting facility, you will find not only IOC's own fire system, you will find BPC, HPC fire tenders are rushing. Along with that, state government's fire tenders are also rushing to have a mutual aid, to have mutual aid support. In case of Jaipur, you must have seen that there was acute shortage of water. How do you overcome that? Through mutual aid partner system. So we are now taking water. Provisions have been made in our system to take water in case there is a problem in IOC installation. You take fire water from BPC and take fire water from HPC or nearby installation. There is a connection has been made into the fire water inlet line. So this type of mutual aid, which has been done long back, should be regularized. I'm sure it is working properly. So level 2 is where you require the help of mutual aid partners. We have already done it. So potential for offsite energy, damage to asset and company reputation. And finally, we do the level 3 offsite emergency. This drill also we are doing. When emergency, that means when we are unable to manage the hazard within the boundary wall of our installation, it goes beyond emergency with offsite catastrophic impact, where population, property, environment inside as well as outside is at risk, and management and control is required by district authorities, which happened with the styrene gas leak, and which happened in Jaipur incident, where continuously IOC was in dialogue with the district administration, and we got the help of district administration. For 11 days, the fire was fought. There was no to the people outside the boundary wall of IOC. Incident, we must have lost 11 lives of our own people and contract workers. But the good thing was that, I'm not saying good thing, the good, well-managed thing was that nobody beyond the boundary wall of the IOC Jaipur terminal, there was not a single injury. Because of good communication, because of the mutual aid system, because of the support by district authorities, because of support of like the lights of NIDM, etc., we are able to contain the catastrophic incident of Jaipur within the boundary wall. Now, let me talk about the performance improvement cycle. I will quickly go through it. I think I'm taking more time. Risk identification is a priority. I mentioned it. I'm mentioning again. For effective crisis management, risk identification is a priority. Planning and control, in which ERDMP development, this has been done, focuses on mock drill. Please conduct the mock drills as it was being done in Indian oil and gas industry on both on-site and off-site mock drills. Implementation, situation assessment, protect life and assets, and implement the plan. And management evaluation is restore and repair. That's very, very important. After anything happens, how do we restore and repair? These 3 things we know: identify the risk identification, and then we do the planning and do ERD and mock drills, implementation, assess the situation, protect life, and finally, when you talk about the management evaluation, we need to restore and repair, debrief, and evaluate the plan. We need to evaluate the plan to see where there are shortcomings in the plan, So that, therefore, management review and improvement is very, very important. Post-crisis review is very, very important. And once you do the post-crisis review, it gives the feedback to the risk identification. It gives the feedback, and thereby the cycle goes again and again, and thereby we achieve an improvement cycle. So that's how we can manage this. It's important. But there are some barriers to effective crisis management, and I will quickly go through it. Denial and failure to prioritize. That's very, very important. We are in a constant denial mode. If we are in a denial mode, we are inviting problem. Then there are situations where there are lack of experience and potential lead. To overcome the lack of experience, NIDM is organizing, and I'm sure many oil companies are also organizing series of training programs, series of educational programs. So thanks to NIDM for organizing such type of programs, which will bring in experience. inadequate system, process, and discipline. If it is there, we need to strengthen our systems and strengthen our processes. Insufficient size and resources. Since you have insufficient size and resources, there are chances. Bring in the help from the outside. Go for mutual aid partners and unwilling to share experience. That is a very, very dangerous thing. Please share the experience. Please share the experience. Let us learn from each other. This platform which has been provided is a unique platform where not only IOC, GAIL, etc., everybody is sharing the experience. NIDM people is sharing their experience. All India has shared their experience. GAIL is sharing their experience. So we must learn from everybody's what sort of experience that they have gone by. Barrier to another effective crisis management if there is a problem with the leadership failure and communication. I mind it. I am harping again and again. Leadership is very, very important. Leader's job is not to only ask for results. Leader's job is to provide resources and direction. Leader's job is not to ask, give me this throughput, give me this output, give me this sale volume. No, that's not the leader's job. Leader's job is to give direction. Leader's job is to give provide resources. Leader's job is to create a team. And how can you create a team? You can only create a team through an effective communication. Therefore, that is very, very important. So we need to overcome these barriers of effective communication. Now, being ready, when you talk about being ready for psychiatrists, at the top, there are 3 critical dimensions for building a well-managed crisis response plan. At the top is the people. People means develop formal and informal arrangements ahead of time, specifying how to respond. That's the preparedness. Develop an informal arrangement. Everything cannot be formalized. Informal arrangement ahead of time, proactively, and specifying how to respond. Preparedness, this is where we are talking about. Analyze your ability to respond quickly. We must know our strengths. We must also know our weaknesses. So analyze your ability to respond quickly and effectively for the possible crisis most relevant to you. So do that study. And what are the possible crises and how we can quickly respond to this crisis situation. And third is rehearse the simulated crisis. And therefore, on-site and off-site mock drills, simulator-based trainings are important. Rehearse the simulated crisis. Create a crisis. Create a crisis and then rehearse. That requires you to show that you have got contingencies covered. If you can do it, if you can rehearse and simulate the crisis, we'll be able to do it. But there are some challenges. The challenge is time is the key element. People are the priority. Task performance and resource constraint could be there, but then we have to overcome all those things. Key information in decision making. Decision making is very, very important. So key information, sharing the key information is very, very important. So whosoever is the decision making process, we need to share the information. We need to communicate with the people. We need to understand that if we lose time, hydrocarbon fire, if you lose time, you will not be able to manage power. The essence is how quickly we respond. So time is key. Share the information. The crucial importance of objectivity. That's very, very important. And finally, I will talk about this slide before I conclude. I think I have overshot the time a lot. Assess the situation. Assess the situation. Secure the area. If there by chance there is some contingency, assess the situation. Secure the area. Activate the incident command system. And through single command system, evaluate the situation. I'm sure yesterday it has been talked about it, so I'm not going into great detail. Ground communication is very, very important. One person must take the command. And I have seen in case of fire, there are too many persons. There are too many people given instructions. Now, if too many people are given instructions, we will not be able to succeed in fighting the catastrophic incidents or in containing the disasters. So a clear single incident command is very, very important. Identify the strategy and roll out the action plan. And finally, you must review, evaluate, and revise that plan. That's very, very important. Call for assistance. External assistance is required. Please understand the well-being of the people. The well-being of public at large is very, very important. And therefore, calling for external assistance is nothing wrong. We have mutual aid partners over and above. If you require some leaders, some knowledge, some domain experts, call them as to how. Because people who have not seen the hydrocarbon fire in their life will simply run away from that place. And most important thing is work together. That's very, very important. So if you don't work together, we will not be able to. So therefore, I always say building a team is very, very important. And when you talk of building a team, it's the job of a leader. Each one of us are leaders. We have our influence of circle of influence. So it's how we build a team. It's how we motivate our team. Because a motivated team can only give results, can create miracles. So we can only motivate them provided we believe that I have trust and confidence in me, and I have trust and confidence in my subordinates. Then we build a team. When we pat the back of our subordinates, when a good job has been done, when we reward our subordinates, when a good job has been done, when we celebrate the success, when a good job has been done, when we communicate with each other, when we discuss the problems, when you jointly discuss the problem and find a solution, then we create a team. And such type of team, such type of communication, such type of discussing strategy will enable us to not only ensure that we have safe situation, no untoward incident, but God forbid, in case there is a catastrophic incident, as I have mentioned earlier, we will to contain the catastrophic incident. Sadly, in case of styrene, it did not happen so much because we have lost some life. But in many cases, many cases, styrene also subsequently they managed very well. But in many cases, in our oil and gas industry, we have been able to contain the hazard, contain the catastrophic incident, and did not allow the danger to go beyond the boundary wall. And therefore, that was our success story. I think with this I will conclude. I thought I will share a incident in the pipeline LPG, not today, sometime next time I will share, because I think already I have overshoot time. It was 45 minutes of time which was given to me. Next time I will talk about this. My final slide is people, not the plan, manages the emergency. It's not the plan, it's the people that manages the emergency. So focus must always be on human resources, on training them, educating them, motivating them. That's very, very important. Because ultimately, people manage the process and technology. Technological changes, technological upgradation has been brought in Indian oil and gas industry, or many other industries. Many process changes have been brought about. Many systems and procedures, best practices have been brought into our organizations. Those are being managed by people. So we need a motivated team. We need a team who has experience, because domain knowledge is very, very important. Unless we have domain knowledge, we will not be able to succeed. So therefore, such type of training, such type of education, such type of interventions are very, very effective. Each of the oil companies are doing. And now, how do you overcome disaster management situation, through which a series of training programs have been conducted, sharing of the ideas have been conducted. My part, I have also thought of sharing this to all of you. Thanks, be safe, and take care. If you have questions, please raise. Otherwise, this is my email ID. You can ask me the questions. Thank you very much. Sorry for overtaking the time.
Thank you, sir, for your presentation. Sir highlighted how to reduce regulation, which are discussed on past industrial incident, namely Bhopal gas tragedy, and lesson learned from past industrial disaster. Sir, there is a question from Vijay Kumar ji.
Your voice is breaking. Your voice is breaking.
Okay, sir. So now it's clear?
Yes, hello? Now it's clear. Now it's clear.
Okay, sir. Okay, sir. Sir, Mr. Datta, there is one question from Vijay Kumar ji. 14 September 2019 incident, drones were used to attack the state-owned Saudi Aramco oil processing facilities in eastern Saudi Arabia. The attack caused large fire at the processing facility. So he wants to know, should we consider such attack in our emergency response and disaster management plan?
See, drone attack will... It may become a reality. It may become a reality. It has happened. See, pipeline, many of the pipelines today, the use of drones are taken to ensure that whether any pilferage, etc., is going on in our cross-country pipeline. We have GPS, we have many other systems, but then help of drone can also be taken to ensure that no pilferage or no other untoward incidents happen in the cross-country pipeline. We have 4,500 kilometers of 45,000 kilometers of pipeline. So use of drone, if drone can be ensured can be used for ensuring the safety of a system, a drone attack, which can be a reality, may not be today, but tomorrow, should also be considered. But then everything has probability. You have to take into probability, and you can build up a scenario that in case this happens, what sort of actions should be taken. I'm sure the district administration, the government of India is well aware of this problem. So a few years back, we never talk about today the computer, the security issue. About 10, 15 years back, we did not think about it. Today it is a big threat to all of us. So similarly, in future, the drone, which has actually happened in some part of the world, may happen in our country also. So we can take a situation like that, because drone, if you are using drone for ensuring safety of the pipeline, by ensuring that pilferage does not take place in the pipeline, the threat of that should also be considered. Yes.
Thank you very much, sir. Moving ahead for our next presentation, we have with us Dr. S.P. Garg, Advisor, HSE, GAIL Limited, India, and former Executive Director, GAIL India Limited, and sir will be talking about disaster risk reduction measure in cross-country natural gas pipelines. He has more than 36 years of experience in the field of fire and safety. Dr. Garg is recipient of President's Fire Service Medal. Now, I would request Dr. S.P. Garg for his presentation. Over to you, sir.
Thank you very much. Good morning. Let me start sharing the presentation first. Yeah. Thank you, Ms. Harjeet Kaur, for the introduction. And very good morning once again, all the audience. It's a pleasure for me to be at this platform. Just hearing to Mr. Hirak Datta, who is very passionate about the subject, and he gave a very nice presentation. So moving on, disaster risk reduction measures in the natural gas pipelines is my topic today. My presentation would have mainly the concept of natural gas pipelines. How do we manage these pipelines? What are the best practices, safe operation maintenance? What are the pipeline integrity management issues? And what are the major hazards of natural gas pipelines? Safety and fire protection in particular, then emergency management, before I conclude the presentation. Now, friends, as we know, the rapid growth of business all over the world has also given a lot of boost to the energy sector, and that has resulted into the increased requirement of hydrocarbon transport capacity. And we know pipelines are one of the safest mode of transportation of hydrocarbons. So let us understand what is pipeline. If you have to define pipeline, it's a system of equipment designed to allow material to flow continuously or intermittently from one location to another location. Now, with sophisticated technologies, the pipelines have advantage over other means of transport due to various economic and safety considerations. If you talk about the natural gas cross-country pipelines in India, India has countrywide network of approximately 17,500 kilometers of natural gas cross-country pipelines, and especially in the northeast region and other areas of the country, we have expansion of pipelines going on, so that in another couple of years, 14,000 kilometers more pipelines will be added. So we will have a large network of about, say, 32,000 kilometers within a 2-3 years time. Now, what are the uses of these natural gas? I think most of us would know. We have a PNG network, piped natural gas, through which the domestic gas is also supplied. There are 72 lakh domestic customers. And then we have a CNG, compressed natural gas, through which our vehicles run. For those facilities, we have 2,290 CNG stations in the country, and more than 37 lakh vehicles are operating on CNG. The third term comes liquefied natural gas, that is LNG. LNG is transported through ships and regasified at LNG terminals. You import the LNG from outside through the ships, and they reach our shores, and there with the help of LNG terminals, the regasification of liquefied natural gas takes place, and it goes back to the pipelines through which it is supplied. Now, India has today 6 LNG terminals with the total handling capacity of 42.5 MMTPA. You know, there is a lot of focus on increasing the energy uses. Today, we have energy uses, natural gas uses energy mix about 6.2%, which is going to be raised to about 15% by 2030. That is the target of the country. We are amongst the oil and gas sector. India is among 8 core industries. Sorry, the oil and gas sector is amongst 8 core industries of the country. And we are second largest refiner in Asia and 4th largest in the world. So there is a lot of energy uses and the requirement. We incidentally have largest CNG bus fleet in the world, which is a very good uses of the natural gas. Now, as we all know, natural gas are highly flammable substance. They are transported through cross-country pipelines at a very high pressure, sometimes through populated areas or through areas of high environmental sensitivity. That is why the utmost care needs to be taken while operating these pipelines. Now, provision of protective measures are essential for safe operation of natural gas pipeline system. These are based on, as I mentioned, hazardous properties in natural gas, because natural gas, if it leaks and it gets a source of fire, it can immediately catch fire. It's a range of flammability is between 5% to 14%. So that means 5% of natural gas, if it is get mixed with the 95% of air, it can catch fire. The quantity of natural gas which could be released from the pipeline and its likely impact, the protective requirements are based on this factor also. As I mentioned, these natural gas pipelines are the safest mode of transportation across the world. However, due to inherent flammable nature of natural gas, such pipeline system also pose severe hazard problems for human beings and properties in the vicinity. What are the major hazards? As I mentioned, they can easily be catching fire. So there could be different types of fires like jet fire, flash fire, or there could be even explosion. Now, if we look at the example of jet fire, this is a small video showing you the jet fire. So jet fire, fire, it's getting protruded on one particular object like a jet. That is called jet fire. Another example is about the flash fire. This is one of the pipeline incident, which is a flash fire incident. Now, if you look at some of the data of the other countries about the various incidents and accidents, this is about EGIG incident data. This is EGIG is a group of 6 European gas transmission system operators. In 1982, they took the initiative to gather the data on the unintentional release of gas in their transportation pipeline system, which is also known as a EGIG group. They have maintained a incident database of 15 European countries on more than 143,000 kilometers of pipelines they are maintaining. So it's a very good authentic data. And when you look at this data, you find that the incidents which they have studied, from the 2004-2013, about 10 years time, the regions behind the incidents were 35% were the external interference, 24% corrosion, 16% construction defects or material failures, 4% hot tapping incidents, and ground movement about 13%, and other unknown regions about 8%. So these are the various regions of the incidents of pipelines which have happened all over the world, especially in the European countries. If you look at our own data in India, the major cross-country accident statistics, this is again 10 years data from 2004-2015. This shows that 29% regions were incident regions because of equipment failure, poor maintenance inspection 7%, poor supervision 12%, violation of work permit system, disregard to SOPs, and all these reasons. So 31% of pipeline incidents you can attribute to pilferage or third-party interference activities. However, 36% incident can be attributed to equipment failure and poor maintenance inspection. So these are the important areas which are controllable, which should be properly controlled, and such incident can be avoided by those control measures. This is almost similar data as I mentioned. This was about PGIG. Now, what are the, as you can see in these from these data also, these are the main 6 regions of pipeline failures: external interference, corrosion, construction defects, equipment failures, hot tap operation, and ground movement, and others. Now, if you look at the external interference, what could be external interference? These are like digging, piling, groundwork, etc., which are going on the ground, maybe by some other agency. This is happening very nowadays when the city gas distribution networks are being laid in the cities. This kind of incidents happen a lot, where the third party comes and he is doing some other construction activity without understanding there is a pipeline there, so they damage the pipeline. Sometimes the construction equipment like bulldozers, excavators, they also damage the pipelines. The casing, sleeves, these are other reasons of damage of pipelines. Corrosion, of course, the external corrosion, internal corrosions are also one of the main reasons of failure of pipeline. Construction defects, material defect, welding defects, or failure of other components, they could also lead to the failure of pipeline. Ground movements, for example, the dike which you have created that gets broken, or erosion and the river banks, etc., or even the area where there is flood-prone areas. Landslides, then mining and other regions. And other reasons could be lightning, poor maintenance, etc. So these are the primary failure reasons of cross-country pipelines. Now, what are the disaster risk reduction measures if you look at the design and construction? While laying these pipelines, these are designed as per the national and international standards, which are like guidelines from OSD, PNGRB regulations, ASME 31.4B API regulations, etc. They are being followed during design, construction, operation, and maintenance. Now, environmental consideration based on the environmental impact assessment and risk analysis study for the pipeline and stations, these are also considered. Hazard and operability study and hazard analysis, these are also considered. Proper layout and interdistance of facilities as per the OSD standard 226 and PNGRB regulations. These are the, I would say, for the Indian industries, Indian operators, these are the mother standards for natural gas pipeline, OSD standard and PNGRB regulations. Now, supervisory control and data acquisition system for pipeline length of 50 km and above, these are provided to have a better control on the pipelines for better monitoring of the pipeline. Leak detection system with provision for identification of location of leak and isolation of affected section from remote operation for pipeline length of 50 km and above. Mind you, we are generally talking about the cross-country pipelines which runs into thousands of kilometers. So there it is necessary to have such system. Besides that, there are sectionalizing walls provided at a distance of not more than 32 kilometers between two walls. This is necessary for emergency isolation. If there is a sabotage or damage of pipeline, then particular sections can be isolated through these walls. These walls are remotely operated and they can be operated sitting at a long distance. So safely you can operate these walls. Provision of remotely operated sectionizing walls to isolate and evacuate the pipeline section. In fact, within the city areas, within last couple of years, we have converted many walls, many isolation walls into the auto-actuated wall. So with the difference of pressure, differential pressure, the wall gets automatically actuated and the line gets cut. This is being done to take care so that the damage in the urban areas where they are more prone to the damage gets minimized by immediate closing of the wall. Now, pigging facility for 4-inch and above size and length 10 km above. What is pigging? Pigging is basically an activity to clean the pipeline from inside. Over the years, when you run the pipeline, the hydrocarbon is passing through the pipeline. There are some kind of accumulation of various impurities, dust, and other things, which are required to be cleaned, because if you do not clean, number one, they can create an internal corrosion. Number two, they can reduce the capacity of the pipeline. So pigging is done from time to time. Now, adequate safety instrumented system designed for the pipeline pumps, motors, engines, storage at receiving or delivery terminals. Emergency shutdown facilities are also provided at the stations, and emergency gas venting system is also provided at each station, say compressor station, sectionalizing walls, etc. Now, if you look at the legal framework, these are the primary standards which I was mentioning, PNGRB, OSD, and ASME. PNGRB standard, technical and safety standards of natural gas pipeline, which we also call as T4S standard. Then for OSD, the relevant standard is 226, or natural gas transmission pipeline and city gas distribution networks. And ASME 31.8 for gas transmission and distribution piping systems. These are the standards which are referred to. Now, broadly, how do you manage these natural gas pipelines so they run safely? SCADA system is provided, that is supervisory control and data acquisition, which increases the efficiency by minimizing fault and response time. And this also maximizes the public safety and site safety. Now, this SCADA complete control is from the respective control rooms. Then you have distributed control room system, maintain the real-time data of all pipeline parameters, supply and operational control of facilities, instant leak detection with the help of remote terminal units, integrity management system through software solutions, instant risk review of asset systems, all assets pipeline data is saved in one central data management system, planning, execution, and tracing of all integrity management activities, integration of existing GIS and ERP system. See, the entire pipelines have been mapped on the GIS, so that if any incident happens anywhere from where even in the remotest area the pipeline is passing and an incident has happened, then sitting centrally, you could know what is the exact location, what are the resources available, what are the nearby villages, where are the hospitals, where are the fire stations, where are the police stations. All those information are, in advance, this has been mapped for all the pipelines. This helps in, early addressing the emergency situation. Then we have nodal control centers in the form of NGMC, RGMC, that is National Gas Management Center and Regional Gas Management Center. They monitor round the clock the leak detection system, communicating and handling emergency. There are also emergency communication system centers, monitoring inventory control. They also monitor the inventory control. And remote operated shut-off valves, facilitating remote closure of valves from the control rooms and rapid closure of valve to control inventory in case of any leakage. Now, these are various, if you talk about GAIL India, how they operate, how they control the movement of gas through these pipelines. In Noida, there is National Gas Management Center, which is called NGMC, and regional gas management center are there all over the country, through which not only the gas movement is monitored, but they are also declared centers for controlling the emergency. Now these pipelines run through an area which has the right of way. We call it a ROW, right of way. An area, say maybe where, depending on the size of the pipeline, it could be 15-meter wide, 20-meter, 30-meter wide land strip where you are permitted to lay the pipeline. So that is called ROU. And where, in case of requirement, you can take your vehicles, your bulldozer, or whatever equipment, construction equipment are required, those, etc. Everything can be taken in that area. No permanent construction is allowed within the ROU area, where the pipeline is laid underground. The road and highway crossings, these are checked, these are inspected once in 3 months. River crossing is also inspected twice in a year, before and after the monsoon. And there is a routine of pipeline patrolling through ground patrolling. Either a person goes from one end to the another end, the specified distance, and checks there is no encroachment of pipeline, there is no pipeline exposure, there is no damage to the pipeline. So in urban areas, once in a week, such ground patrolling. In fact, in urban areas nowadays, it is almost every day the ground patrolling is being done. And aerial patrolling once in a month through helicopter. We are patrolling the entire pipeline, because it is easy to locate any encroachment or any new construction happening in that area. Immediately photograph is taken and the action is taken to remove that. Foot patrolling, as already mentioned, by even the GAIL personnel also does the foot patrolling after the monsoon, and night patrolling. Pigging, pipeline pigging, as I was mentioning, there is one activity which is called cleaning pigging. This is necessary to be done regularly once in a year, so that there is no accumulation of dirt and other impurities. And there is another thing called intelligent pigging. Intelligent pigging is to be done at least once in 10 years to compare the internal data which you have gathered over the baseline data when you have laid the new pipeline, and then find out internal defects in the pipeline if there are any, and take the corrective actions. Now, if you look at this small video, it shows how the pig runs through these pipelines and how the threats are identified. This is a kind inline tool which we call it intelligent pig, which is inserted in the pipeline, and it runs in the pipeline and it continuously scans the internal of the pipeline, so that you would know what are the defects if there are any. See the deformation immediately noticed, and that will come on your computer. You can immediately plan measures to rectify. Mechanical damage, that was also immediately noticed. General wall thinning. So wall have been thinned. So naturally that section needs to be replaced. Seam belt failure. So that is how it is. Now, inspection of cathodic protection system. Now you know that to save the pipeline from external corrosion, cathodic protection is provided. This cathodic protection is required to be inspected through pipe to soil, measuring the pipe to soil potential at a feeding point. So this is done once in a fortnight, which is called PSP. PSP reading at test lead point all along the pipeline is also done once in a 3 months time. And the coating survey, the pipeline is provided with a coating, so to prevent from it external damages. So these coatings are required to be surveyed. Various kind of surveys are there to ensure the integrity of the coating. Pearson survey, direct current voltage gradient survey, continuous potential logging survey, and so on, so forth. Now there have been incidents of intrusion, as I was telling you. So today there is a technique to detect the pipeline intrusion detection. If suppose somebody is planning to intrude a pipeline, somebody planning to damage a pipeline, or is unknowingly doing some moving some tractor or some other equipment over it, through this pipeline intrusion detection system, you can immediately know in advance that some activity is happening, and from the control room, the message will immediately go to the rapid action force, which are generally provided these days, especially in the city areas, to immediately rush to the site and stop such unauthorized activity. Besides that, you have operation maintenance written down in various SOPs are properly written down, and then you have all lot of operating procedure manuals and maintenance procedures for entire pipeline system, considering the requirement of Oil Industry Safety Directorate and PNGRB. If you look at some of the best safe O&M practices to maintain safety in a manner consistent with the specified requirements of national international codes and standards, to provide latest process safety information, to formulate SOPs and to revisit those SOPs. We revisit all the SOPs at least once in a year, and within the plant facilities, the SOPs are even revisited once in 6 months. And the operators are involved in rewriting the SOPs, and some of the locations we have also started their consent, their written consent that they have understood the SOP. And also we have made some animated films for better understanding of SOPs. Another one is to implement integrity management system to minimize the probability of failure of pipeline and to keep focus on quality of outsourced manpower. A lot of outsourced manpower is taken in oil and gas industry. So the quality is to be maintained. They should understand what are the risks, hazards, and how to combat those hazards. Engagement of employees having minimum qualification and experience as per the various codes and provisions and also engagement of subject matter experts on aspects like pipeline corrosion, cathodic protection, inline inspection, coating survey, metallurgy, welding, etc. We have hired such subject matter expert. They provide their expert opinion from time to time. We also developed in-house manpower with the required skill and certified professionals like NACE certified corrosion experts for the pipeline safety. As I was mentioning, all the pipelines have been mapped on GIS platform containing all the pipeline related information along with the satellite imagery and cadastral map, etc. And we have also created centralized pipeline integrity management system based on risk-based analytics software. In fact, we have created a specialized group within the company which are called CIMG, Centralized Integrity Management System Group, and the RIMG, Regional Integrity Management Group. So their main purpose is to focus on the pipeline integrity management. Leveraging IT in safety functions like work permit system, incident accident reporting analysis, risk assessment, compliance, etc. Integrity management tools, you have already seen that Intelligent Pig. Then these are the other activities which are done from time to time. Thickness assessment and periodic reviews, pressure testing, and other things which I have already mentioned. Now have a small video of 5 minutes. You can look at the pipeline technology.
A surveillance plane flies a pipeline radar, a watchful eye. In this movie, we're looking at technology at work in pipelines, cathodic protection so the pipeline doesn't rust, how leaks and hazards are detected, critical inspections inside the pipeline, and the marvel of directional drilling. So let's begin. What if a machine were to damage a pipeline's protective coating? Bared steel would naturally turn to rust. Pipelines have protection against rust. Along the pipeline, they install what are called anodes and supply small amounts of electric current. The current flows through natural ground moisture to the pipeline and redirects where the corrosion will occur. Pipelines have been doing this for decades now. The current encourages the anodes to corrode. The pipeline becomes a cathode and is protected from rusting in case any steel has somehow become exposed. Pipelines have leak and hazard detection. In this new system, a continuous stream of data is collected and transmitted by next-generation fiber optics.
The fiber optic is both transmitting data, but more importantly, is actually acting as a sensor on a fully distributed basis along the length of the pipeline.
Measures acoustic, strain, and temperature. Temperature accurate to within 1/100th of 1 degree. Pipelines are run from sophisticated control centers fed by thousands of data points. Let's say there's a heat buildup from maybe a forest fire. A display will appear in the control room and then a warning. What if someone tries to maliciously damage the pipe? The operator sees this warning. What if there's stress on the pipe, frost heaving, machinery that's too heavy? The operator would get a strain warning. And if there's a leak, a small nitrogen stream here is simulating a leak, and the control room gets a display and an alarm. Pipelines track detailed data about each length of pipe in their pipeline. But now technology allows them to track more easily and reliably and track a lot more information.
Pipe ID, the heat number, length, diameter, wall thickness, basically, and the steel grade, the most important.
Pipelines depend on inline tools commonly called fittings. Most times they're for maintenance. Often they have brushes to clean the pipe. But there are also smart fittings for early detection of problems, bristling with technologies to identify wear or cracks usually too small to see. Powerful magnetism, hard drives, and GPS track. The odometer measures to within millimeters where anomalies may be. This module sends sound waves around the pipe's circumference. multi-million-dollar tools to detect trouble years in advance. Data from a smart pig brings us to look at horizontal directional drilling.
We're at a highway bore here doing some directional drilling underneath the highway.
Directional drilling because the smart pig has found an anomaly in a pipeline, but it's under a 4-lane highway. You can't close the highway to dig up and inspect the pipe. So they will drill to install a 1/4 kilometer of replacement pipe under the highway. Computers tell them what to expect in a situation like this.
There is a buried cable here, and we have requirements to go like 3 meters underneath those cables.
One amazing thing is how they can so precisely track and steer the drill bit. Drilling begins, and they have lots of pipe lengths to extend the bit as they continue and reach under the highway. The key is this tracking device that tells them within an inch or so where the steerable bit is.
We have our pitch. What position are we steering?
And on the other side of the highway, they have steered the bit exactly where they want. Our best protection is still here. Here, the pilot's trained now, still best knows what to look for. But a good digital picture, technology, helps the pipeline company know what's going on along the many kilometers of its pipeline. Good people making good use of good technology.
Of course, this is a latest technology which may not be there everywhere, but these are the measures which are coming up, and many of the measures already. Pipeline surveillance through drone has also started, as Mr. Dutta was also mentioning. So it's a continuous improvement thing, and the pipeline industry, oil and gas industry, investing a lot of money in the technology, and technological advancement are regularly happening. Now, if you look at the safety, health and management, environment management, like every company, you have the HSE policy statement, which is signed by none other than the CEO himself, which gives the guidelines, which gives you direction on how to operate the safety management within the company. A set of detailed processes supporting each activity of HSE management system, development of operation maintenance procedures, implementation of control and monitoring activities, periodic monitoring, review and reporting of performance. We have a system of observing monthly safety day on 10th of every month, wherein every site has to devote compulsorily half day reviewing the safety management at their site. So if there is a pipeline headquarter, then the head of the pipeline, maybe either ED or GM, he will sit along with all HODs, and that day on 10th half day, they will review. There is a format against which they will review the safety preparedness, all the safety audit points, safety suggestions, any recent audits done or not, whether the compliance of these audits, all those status they will review and put up a report to the corporate office, which is compiled. And last week of the month, there's those reports, the exceptions which are there from the sites. There are two things done. One is exceptions are taken out, and one is HSE score is also worked out for each site. And that is compiled and put up to the directors, two of the technical directors, who in turn call a meeting of all the EDs and GMs and senior people of operation maintenance all over the GAIL, and they get connected through VC, and then the HSE corporate department, they monitor, they liaise complete meeting, and they organize that meeting, and these issues are discussed, that why there is a delay in the compliance of a safety audit point, or if there is any other exception, the mock drill could not be done, what are the reasons. So through this practice, the leaders are involved, and leaders understand the importance of completing all safety activities on time. And the score also, individual sites HSE score also reflects on that, and the combined score of GAIL works out every month. Earlier days, even we had MOU with the government that certain amount of certain value of the HSE score will be there for a particular year. So that gives you a lot of opportunity to understand that this activity is also important, and leaders are encouraged to focus on these activities. Then you have compliance audits as in other industries, accident reporting system, hazard identification process such as HAZOP, etc., work permit system, structured training system. Work permit system is also nowadays on SAP. For the remote areas in the pipelines, we have also enabled the mobile operated the SAP system so that you can take a work permit through mobile also. Management of change procedures are very rigorously followed. Awareness program for the surrounding villagers. We have a scheme called GAIL Sayogi scheme, through which you rope in the villagers, through which the pipelines are going on to villagers of those villages, so that they become your ears and eyes, and they are the first person to report in case of any encroachment, any leakage from the pipeline. And there is a toll-free number, 5-digit, very easily remembered, 5-digit toll number. They can call on that number, and the call reaches to the nearest RGMC, and from there the action happens. Public awareness measures through the radio jingle, videos, then Nukkad Natak, skits, etc. is being done. And engagement of villagers, as already mentioned. Collaboration with government authorities on management of emergencies in hydrocarbon pipelines. So I will not go into detail of the fire protection system. This is just a glimpse of it, that each site, especially the gas compressor stations, wherever the compressors are provided to boost the pressure. So there the elaborate fire protection system is provided. These are as per the standards and sometimes beyond the standard also. Installation of gas detection system, that multi-sensor detectors in the control rooms for detecting any smoke or fire, then hand-operated sirens for small installations, and other locations you have the electrical sirens which can sound up to 5-kilometer distance, and other provision of firefighting equipment like fire tenders, detailed pumps, then pipeline system, and hydrants, monitors, etc. provided at these compressor stations. Fire water demand you work out, you also have the, naturally after working out the demand, you have the fire water storage in place at these compressor stations. And of course, this is connected to the pump house and the hydrants and monitors. This is a view of one of the pump house, just to give you a glimpse of this. This is a fire water pump house and storage tank. Various systems, CO2 flooding system for protection of machines, then FM200 provided in SCADA room, then smoke detection system for substations and other buildings, water space system provided in filter operated areas, filters, pipeline filters, and other field areas. Now, finally, looking at the disaster management legislations in India, I think earlier speaker might have talked on this, so I will not delve in detail. We know that Factories Act, MSISC rules, then CA, PPR rules, that is Chemical Accident Emergency Planning, Preparedness and Response rules, Disaster Management Act, ERDMP 2010, this has been discussed. These are various rules and regulations connected to the disaster management. Overview of ERDMP. See, emergency response disaster management plan is to be prepared for each installation, for each pipeline. In fact, the recent revision of ERDMP regulation, I happen to be part of the regulating the revision committee, and this is one of the changes brought in, that you could also have either one document for the entire pipeline, ERDMP, and the local document for containing the information with respect to telephone number and the person and the flow chart, etc., could be attached to that document. That is one option. Second option, as being done earlier, you could continue with the separate ERDMP for each compressor station or the pumping station, as per your the entity's convenience. Now, the 5 parts of the emergency response disaster management plan are pre-emergency, emergency mitigation measures, emergency preparedness measures, emergency response measures, and emergency recovery measures. So I will not go into detail. I think you would know all this already. But there is a change in approach these days over the period of last couple of years. Conventionally, there used to be rehabilitation, reconstruction, response used to be the focus area. Today, the focus is on planning, prevention, mitigation, and preparedness. This is the modern approach to have to handle the disasters in a better way. You do the prevention, you do the planning in advance, so that even if the incident has happened, the damages will be less, the losses will be less. We have robust legal framework, and there is a focused approach and implementation of safety management system. This is being realized by the organizations. They are also building good safety culture and good safety management system. Trust on the relief-centric approach for a proactive assault on the vulnerabilities through risk management measures. Your approach has to be risk-based thinking. Risk-based thinking is important to realize that you have risk with you, but you have to bring it to the LRP level, that is as low as reasonably practical levels, and operate the facility safely. Extensive efforts towards capacity building of community and industrial personnel. As I was mentioning, those villagers are also being trained. They are being sensitized on what can go wrong, how pipeline leak can create a havoc there. It can create fire, it can create explosions, so what damages it can do to them and others, so that they realize that these are the risks and they also become more alert. Streamlining institutional arrangements for disaster response. In spite of all this, if you look at today's scenarios, the future challenges of energy pipelines lay in the overlapping regulations. Today you have many overlapping regulations, OSD, PNGRB, then even the other regulation acts. There are overlapping provisions which industry is facing difficulty. PASO has different rules, regulations. Societal awareness, this needs to increase. This is another challenge. And rapid urbanization nearby pipelines. Pipelines are laid before, but the urbanization is taking later, and it is taking at a very rapid speed. So it becomes really difficult. The urban population gets exposed to the pipeline hazards because of this. And every time it may not be possible to move the pipeline away. Third-party damages are increasing. People are not sensitive. They are not trying to understand exactly where the pipeline is going, which could be dangerous. They just go and start their excavation work or the civil work. This is happening, especially in the city gas distribution. It has happened so many places again and again and again, and people, even though district administration is also supporting, they are also warning them. Some of the cities, they have made good systems wherein the other agencies are forced to take prior permission before carrying out any civil activities, but others have to still learn. There are some encroachments which are happening on the ROU, which is detrimental for the not only the pipeline, but even the encroachers, the people around. It is harmful for them also. An absence of nodal agencies. In city area especially, we find that so many civil agencies are working. For example, metro station was being built, and if you remember in Dhola, there was a big fire because one of the pipeline got damaged. So it was felt that there should be a nodal agency which controls the construction activities, all kind of construction activities, that it be metro, railway, bus, or civil, or PWD, or GAIL, or ONGC, IGL, whatever. So that will help in streamlining and avoiding the damages to the pipelines. And this is my last slide. Disaster risk reduction and natural gas pipeline system is achieved through continuous efforts at all stages to ensure that pipeline is designed, commissioned, operated, and maintained as per the stipulated guidelines and best practices, besides following applicable codes. Thank you so much. You can see my email ID. Of course, we can take up some questions here, and who are not able to ask the questions, you can also mail me. Thank you so much. Thank you, NIDM, for giving this opportunity, and thank you all the listeners for patient hearing. Thank you so much.
Thank you very much for highlighting measures to reduce natural gas pipelines disasters across the country. Sir, there are few questions raised by Mr. Vijay Kumar ji. Sir, he asked why 4 hours minimum fire water requirement is mentioned in OISD. Have been continuing for days. How this 4 hour is adequate?
See, first of all, this question is not related to today's presentation. But in any case, since the question has been asked, see, 4 hours is considered as a reasonable time wherein a fire could be extinguished. If you are talking about a gas compressor station or any other installation, oil and gas installations, this is quite a reasonable storage, fire water storage, and the other resources, because you have to have cutoff. You cannot store, say, a 12 hours firefighting storage. Then you have to strike a balance. You have to strike a balance that how much is practical and how much is generally required. So keeping those guidelines, those points in mind, it has been designed that maximum 4 hours is enough for a large fire to be extinguished. Yeah, madam. Hello?
Hello, am I audible, sir?
Yes, now you are. Any other question?
Yes. Next question is, what about process safety management practices in industry? Will that be made compulsory as in other countries?
It is already compulsory. If you look at the MSSISC rules, all the process industries are required to have a good safety management system. And they do have process safety management. I don't think, if you look at the oil and gas industry, any of the industry you talk about, IOC, GAIL, ONGC, they all have process safety management systems. Even yesterday, 2 days back, I was in the panel discussion which was arranged by HMEL, HPCL, and Mittal Energy, the joint venture. They even have a PSM department. Even Reliance has got a PSM department, dedicated department, where the professionals are only focusing on the process safety management. So it's already there. It's basically some of the small industries who are not realizing that having a good safety culture developed in the organization is important, and for that you need specialists who could look into the process safety management and other safety management areas. That such incidents happen sometimes, which are outcome of not having a good safety culture in the organization. Yes, PSM is important.
Once again, thank you very much, sir, and this answer will satisfy. As our next speaker will join us within a few minutes, meanwhile, I will request Mr. Anil Kathad to guide our participants. Yes, sir.
JD sir is with us. Please invite.
Okay, sir, I'll invite him. Sorry for that. Now, for our last presentation, we have with us Lieutenant Colonel Dinesh Chandra Vasishtha, Joint Director, NIDM, and sir will be enlightening us about the IRS, IDRN, and supply chain management. Lieutenant Colonel Dinesh Chandra Vasishtha is presently the Joint Director of National Institute of Disaster Management, Ministry of Home Affairs. He was commenced into Army Ordnance Corps in September 2000. Lieutenant Colonel Dinesh Chandra Vasishtha is a supply chain management professional with over 20 years of experience in managing the entire gamut of supply chain grid. The officer has excelled academically with master degree in management apart from logistic management courses with specialization in ammunition and other war-like stores. The officer has commanded an ordnance unit of prestigious Strike Corps of Indian Army and have exposure on various command and staff duties in all type of operation and terrain. With these word, I would like to pass on stage to you, sir.
Thank you, Dr. Arjit. Thank you, Dr. Arjit. Am I audible?
Yes, sir.
Okay, thank you so much, and thank you for inviting me in such a prestigious program wherein gatherings like Dr. S.P. Garg has just spoken, and I just heard him, and with his enlightenment to this gathering, and I'll be just taking over the subject of I have been given the subject today as the IDRN, the Incident Response System, and the Supply Chain Management, how it is connected and how it is connected in the entire gamut of disaster management plans, and what is NIDM doing in this entire gamut of things. So with this, I would like to start my presentation with a basic on the supply chain, since we all know that how important the supply chain as such is. So we all have shown this slide, but however, I will reiterate again that wearing a mask is how important it is. Wash your hands with soap and water. Avoid touching eyes, nose, and mouth. Keep social distance. Clean surface regularly. Since we all are talking about the disaster, and today we are dealing with a pandemic, which is much more than a disaster, and the entire world is in the grip of this coronavirus. And till the vaccine is made and is made available to all, these 5 factors which have been the prevention measures which have been enlisted on this slide may be followed by each one of us, and we should always inculcate this education in our colleagues, friends, and families also. With this, I will start with the topic in general, supply chain management. It is the I'm speaking to the reps from Indian Oil Corporation, and we all know that how important this supply chain is, and then I will connect it with the IDRN, how it is in the plans as a disaster management for Government of India. So first, I will try to give a generic term supply chain management. I'll try to describe this in generic sense, and then I will take it to the IDRN and the response where I'll be speaking on further. So supply chain management is a sequence of, we all know that it's a sequence of suppliers, transporters, warehousing, manufacturers, pipelines in your case, wholesalers, distributors, retail outlets, and the final customers. So it is a process, it's an activity wherein the sourcing of raw material up to the making it available to the end user, the entire process and the processes involved in this to manage that particular aspect is known as supply chain management. The most, this is another graphical form of what I said earlier, and the customer management, the supplier management, and the entire gamut flows in the material flow and the information flow both ways is supply chain management. In petroleum industry, we all know, we are all dealing in petroleum industry, that the material till it reaches the consumer is the supply chain management, from the raw to the end product. The entire chain is the supply chain management, and in this, supply planning and distribution planning are the major things in petroleum industry. Planning, sources, making, delivering, returning, and enabling are the components of supply chain management in stages in petroleum supply chain: exploration, production, refining, marketing, and consumers. And the objectives for the supply chain management for any supply chain manager is the minimization of the material procurement, maximization of the manufacturing capacity and sales, meet demand numbers, respond to market, maximize throughput and its margin, and procurement, best yield at low cost. One of the major aspects of supply chain is the inventory management, apart from the warehousing and the transportation. The as we all know that during the COVID-19, this will go with all types of disasters. If you see this slide, will connect with all types of disasters. The government restrictions in any emergency situation, any disaster, may be it a landslide or an earthquake or a flood. So the government restrictions or the restriction itself, that the road breaks down, the transportation system, it breaks down, the pipelines, they may get disconnected, the availability of the labor, the manpower to basically to clear that particular line, or for the loading, the raw material processing and everything. So the labor availability also gets restricted out of these things. So in lockdown, we all know what has happened in corona, in these times when we were all placed under lockdown. This is the first time and it was unprecedented. But we have learned that this situation can be with any type of disaster. Non-availability of the raw material, transport not available, negative sentiments of the buyers were not coming. The demand for the petroleum and the oils and lubes had gone down, as we all know, during the times of disasters, this pandemic, when we were under the lockdown, because as a normal citizen, people are not aware that what would be the next step and how this coronavirus is going to behave, and what would be the directions received from the government on this handling of this particular disaster or pandemic. Perception of scarcity amongst the masses led to hoardings. So the demand planning of each company went haywire. Once the demand planning had gone haywire for various types of items, so the supply chain and the supply chain management got disrupted. The credit and cash inflows, of course, there was no movement of any material, anything. So this, the cash and credit also went through a negative sentiment. So what do we do to prepare for these kind of contingencies, to these kind of crisis situations? Create a contingency plan wherein we should see during the time when we are sitting today and when we are discussing. So this is for every type of like condition or the situation where we face any situation, any emergency situation. So everything would be the same, but these are specific to the supply chain, because the supply shock, since we have various suppliers, so we should diversify the supply base, manage demand volatility, the panic buying and other things should be managed, and they should always be kept in our contingency plans while planning the things. Now we know that, and we have gone through the corona times, and we have always gone through various disasters. Like if the Indian oil is being supplied to the state of J&K and it is kept in various oil wells there, but however basically the store houses, but however in case of the roadblock, the NH1 or the anything breaks down due to landslides, this entire supply chain gets affected, and the consumer is the person who is not getting the finished product at the right time. So these kind of scarcity situations, these the alarming situations should be avoided when we plan. We can plan the contingency at in these times when we are trying to plan and we are trying to tell about the prevention measures. The workplace safety is very important. The protective gear supply for various workers, as we know that we are going through this pandemic. However, during any type of emergency situation, like in case of floods, we should give them the protective gears like the life jackets and all. So we should have everything should be planned during the normal times to deal with any kind of disaster. The way forward for any handling is the establish a task force leveraging latest tool, techniques, data analytics to create a transparency in the entire system, establish a long-term, short-term, and mid-term goal for meeting any demand supply chain or making availability of the workforce. Government support should always be seen, and the various industries, partnerships and synergy should be made so that to deal with any emergency situation, prepare for the upswings history shows and the struggle. So how do we integrate this supply chain in our plans? As we all know that these an IDM is as per the Government of India DM Act 2005, we have been given a responsibility of the capacity building to make the Indian states and the districts and the normal Indian citizens to make them privy to the disaster and to how to handle these disaster situations. So the supply chain factor in this, the availability of the inventory which will be utilized to fight various types of disasters. So this becomes very critical in times of requirements, in times of emergency. And inventory like the firefighting equipment, inventory like the ambulances, the resources, the ambulance drivers, the cranes, the JCBs, the various types of hammers, various types of boats, life jackets, and things like these. So this inventory is required during various types of disasters. So how do we make this available to the place where the disaster has struck, to the people where the disaster, who are the most affected during the times of disaster? So the entire supply chain in this, how and where this inventory would come from, a particular network has been made, which is known as the India Disaster Resource Network. Since India has got a varied geoclimatic conditions, so we are vulnerable to varied kind of hazards, floods, earthquakes, cyclones, landslides, and tsunamis. And as we are going through the current pandemic of coronavirus, one of the major challenges for the disaster managers or the managers who are looking after this particular aspect, this subject in the states or the districts or the villages, talukas, is the lack of availability of the inventory in that particular place, or the knowledge where this inventory is lying. So this was felt, and this was one of the limitations which was felt at the government level here in MHA. In 2004, along with the United Nations Development Program and Disaster Risk Management, a systematic inventory management resource network was built, and which is now known as IDRN. And in 2008, it was given to NIDM to manage this particular portal. The primary focus was to make the decision makers to access the equipment and human resources required to combat any emergency situation. So this management of this inventory, which is required at times of disaster for any district administration, it was a major Herculean task because they were not aware where the items are kept. So this portal has been made, and in the past, with our experiences with various disasters, this inventory portal has have helped the state disaster management authorities to save many lives in times of disaster, because the items are shown on this particular portal and they are available at one particular click to the state district administration. If there is a fire, or if there is a flood, or if there is an earthquake, so the inventory has been categorized in those particular themes, and a list of 289 items have been put on this particular web portal. The list has been vetted by the National Disaster Management Authority with a committee under their chairmanship, with the MHA and IDM and the state reps being part of that. So till now, we have identified that 289 items are quite critical in times of disasters, and the criticality is, if the criticality is for Kashmir, the same criticality is for the Kerala state or Tamil Nadu. So those critical items have been listed out on this particular portal, and the updations, the condition of that inventory, the time, the shelf life of that inventory, the geolocation of that inventory, everything is being tagged here and is seen online by the district administrations at any point of time. So this particular portal is managed by NIC. This is the infrastructure in front of you. It's on the NIC portal, synchronized on its server, a highly secured platform. In past 3 months, we have had about 2 cyber attacks on this portal, because enemy elements, the inimical elements they are looking for are preparedness during the disasters. So, and now since the database for the private sector undertakings and the private sectors is also being integrated, Indian Oil Corporation might have also received a letter from the PMO or the NDMA that your database to fight this any type of hazard, a list of inventory has been circulated for these 289 items. So this needs to be sent to the district administration for updation on this particular portal. So So it is available on internet. However, we are developing an offline mode also. There's an API which we have just developed and given to the state or departments to make their own inventory management program and to take our database to integrate into their plans. There are 4 forms, so I'll not go into details, which are given to the line departments, and they fill those forms, send it to the district administration, and from there, district administration is the lowest chain in the entire plan for this IDRN portal, who feeds into the data into this portal. Here in MHA, the data is put up to the Union Home Secretary every month and is being sent to all the chief commissioners to see the status of their updation and to see where the database needs to be pulled up or where there is a requirement of inventory in these 289 items to be updated or to be maintained to fight any disaster. So all the aspects of this inventory management or the resource management portal are seen at here in NIDM. All the 36 states and union territories are registered on this portal. Out of 740 districts, 721 have been registered, and the balance are in the process due to the internet connectivity issues with the districts being far-flung. The data is being sent to another districts to be updated from that particular site. But we are in a process to set up the network systems at those districts also, and to integrate in our plans. This is a slide for the API, which I have already briefed. This is the dashboard for that IDRN portal. And if you can see that all the states and districts can see the data on what is the status of their database in this particular portal. This we have just inaugurated, this new interface, new portal we have inaugurated on 1st of June 2020. It's a quite user-friendly, and the database can be utilized by anyone in the state or district administration to fight the disasters. These are the contact details in case you feel that more information on this IDRN portal can be you need, we can share with you. With this, I come to the end of the presentation, the topic which was given to me, how we handle the supply chain aspects and the inventory management as part of the DM Act, and where what is the role of NIDM in this entire game of the disaster management. So any questions, we are open and we'll be glad to answer.
Sir, for highlighting about supply chain management and IDRN portal developed by NIDM. Like sir mentioned about the inventory serve as a useful purpose in the supply chain. We need to have a list of inventory so that it can be used more efficiently at time of need. Sir, as such, there is no question raised by participant. If there will be any question, we will let you know, sir.
Thank you so much. Thank you, Dr. Harjeet.
Thank you, sir. Now moving ahead to our group exercise, I request my colleague, Mr. Anil Kathar, to guide our participant about today's group exercise. Sir, over to you.
Thank you, Dr. Harjeet. Dr. Harjeet, notify me once my PPT are visible.
It's clear, sir. You can proceed.
Okay, thank you. Good afternoon, all of you. Based on the lectures that were delivered on day 1, you were given assignment on to identify hazards and vulnerability assessment in which you were asked to identify hazard that can affects your area that where you are deployed presently, and what are the chances of occurrence of those hazards, and what is the degree of vulnerability of those hazards in your area. Which hazards has low vulnerability, which one has medium one, and also those hazards which have very high vulnerability in your area. So carrying forward to day one exercise, today's assignment will be based on will be for developing a disaster management plan for your office to which you are attached, considering the hazard that are that have high likelihood of occurring in your area and high degree of vulnerability for your area, for your department, your office. So based on the yesterday's and today's technical session, the topic you have to cover in your plan are first you will cover a profile of your office, in which you will describe the activities and responsibilities of your office, and second one is vision of the plan, in which you will describe what's the need to develop this plan and what you want to achieve through this plan, what will be their objectives and aims, basically a synopsis of the role what you will be having in your disaster management plan, what the scope can be to improve the state of preparedness to meet any contingency, or to reduce response time in organizing the assistance, or to identify major resource or manpower, material or equipment that are needed, and how you will be using your available resources. And next point is a time frame. A brief note can be provided in this section about how timelines have been considered in this plan. Activities, whatever you have planned, can be categorized accordingly in short term, and for medium term, and for long term. And next point is hazard, risk, vulnerability, and capacity analysis. And in this part, your yesterday's assignment, you will put your yesterday's assignment, and for effective planning and process. It is very important, and very first step is to understand the hazard, risk, and as well as our strength and what are our weakness and threats we are prone to. So the yesterday assignment will be described in this section under hazard, risk, vulnerability, and capacity analysis. And next one is topic will be on hazard specific prevention and mitigation measures. After hazard, risk, vulnerability, and capacity analysis, you must formulate certain action plans for mitigation, for better preparedness against each of the disasters that have high degree of vulnerability for your department or for your office you are currently attached with. And this hazards and intervention of risk need to be prioritized based on their severity and the vulnerability of your office. And next, you will describe how you will mainstream the DRR. What are the strategies to include the DRR in your day-to-day activities for sustainability of the development gains, mitigation, and prevention? In this section, you will basically describe your strategies that you are going to adopt for mainstreaming the DRR in your daily-to-daily routine work. The next one is about preparedness and response. You have to lay certain strategies, certain points, activities for preparedness and response, like for early warning for your alert system. You will be having, you can define precautions like do's and don'ts. You have to explain common terms for response planning for various disasters. Disasters specifically that have high degree of vulnerability for your area. And another one is capacity enhancement. What will be your strategies? The strategies you will adopt to enhance the capacity of your officials, the stakeholders, or of the local communities that are residing around your areas. And next one is budgetary procurement. As I have mentioned in my yesterday talked that a plan and disaster management cannot be successful without suitable budget provision. So there should be a budget provision for different activities for different phases of disaster management. So you can describe what kind of budget provision you want for your plan and the activities you have considered in your plan here. And the most important part of the disaster management plan is its implementation, how you will monitor your plan is going well or not, and revision. So you need to brainstorm how you will be implementing your plan and framework of monitoring setup, and depending upon the need and necessary periodically updation of your plan. So this is the assignment you have to complete for both the days, and participants are requested to prepare a presentation on the given assignment on first day assignment of hazard identification and vulnerability assessment, and today's assignment on developing a disaster management plan for their office. Basically, we will make a group based on the locations of the participant, like Panipat. Some of you are from NRPL Panipat, so NRPL Panipat participant will be in one group. Gujarat refineries people will be in one group, and so on. We will make the group, and we will notify you through the mail about your group shortly. And tomorrow, all of you will be presenting your assignment. So be prepared with the presentations. And that's all from my side, and thank you. Over to you, Dr. Kaur.
Thank you, sir, for highlighting about the group exercise. Now it's my privilege to propose a vote of thanks. I wish to express my sincere gratitude to Mr. M.R. Dwivedi, CGM, Indian Oil Corporation Limited, and Major General Manoj Kumar Bindal, ED NIDM, for their encouragement and support to organize this training program. I must mention our deep sense of appreciation for our distinguished speakers and today's session speakers, Shri Hirak Datta, ex-IOC, former ED, OISD, MO, PNG, and advisor and head safety, Naira Energy, Dr. S.P. Garg, advisor, HSC, GAIL India Limited, and former executive director, GAIL India Limited, and Lieutenant Colonel Dinesh Chandra Vasista, joint director, NIDM, to enlighten the participants with their vast knowledge and experiences. I also express my deep sense of appreciation to Professor Surya Prakash, head GMRD NIDM, who is the program chair of the training program for coordination and support. Last but not least, I am thankful to our GMRD team, Mr. Raju Thapa, Mr. Anil Patat, coordinator of the program, and our IT team, Shobhit, Balaji, and Gaurav Sinha, for making this event successful. We are also thankful to our participants, also for making today's session successful. On behalf of NIDM and IOCL, we wish all the participants a healthy and safe life. Stay healthy, stay safe. 2 गज की दूरी और mask है जरूरी to fight against COVID-19 pandemic. And please join us tomorrow at the same time using the same link. Thank you. And now I request the host to end the meeting.
Okay, thank you, Dr. Kaur.